Okay, today we discuss about lecture number 2 in module number 1. Okay, lecture number 2 in module number 1. So here we are going to talk about number systems. Number systems. Wait, yeah.
Sir, you didn't told about advantage of digital system.
Yeah, I'm going to tell you that one. Okay, so don't worry. So let us recapitulate what we have seen. Okay, let us recap. Okay, so in the last class we have seen what is the typical digital system. Okay, so we have seen the typical digital system is all about. Okay, so how the digital system look like and what is its main functionality that we have seen. Okay, now the thing is that as we have seen that there are some advantages are there for the digital system is because of the nature of the digital input. Okay, so by the nature of the digital input, the system is very popular. Okay, so based on the data input, digital systems work better manner. Okay, based on the data input, the digital systems are work better. Okay, work better. So why the how the data input is represented? Okay, as we have seen that the digital input is represented in this way. Okay, so for any digital system, for the matter, if you take any digital system, right, the input and output that we have considered, so that means there is an input is available here, so we will get an output after processing of the input. Okay, so this input is actually a digital input. What is the input is it? It is digital input or digital information. Digital information we are giving as an input to the digital system. And again, we are getting the digital information as an output, right? So what is the advantage of taking this digital information, the information as a digital information? That means, so we are going to consider the range of the for example, in case of the information is in the form of electrical signal, electrical voltages. Okay, so it is an electrical voltages that we are treated as an information. So this information we are taking as a logical information, not in the point of physical voltages. Okay, so the advantage of taking this one is we are considering only the ranges of the information, the ranges of the signal. So as I mentioned that the information, signal, message, whatever the name that we can give is okay, but it is apt to consider as a signal. Okay, so the ranges of the signal that we are considering. What does it mean? That means whenever we are applying from 0 volts to 5 volts as an electrical signal as an input to a system. Okay, so from 0 volt to 5 volts, you can see n number of so many number of divisions can be possible. Okay, for example, you consider that so 0 volt, after that 1 volt, 2 volt, 3 volt, 4 volt, 5 volts, something like this, or otherwise you can consider 0 volts after 0.5 volts, 1.1 volt, 1.5 volts, 2 volts, 2.5 volts, like this n number. So infinity number of ways that we can present here. There is no doubt at all. Okay, so for example, 3 volts, 3.5 volts, 4 volts, 4.5 volts, something like this, and 5 volts. Like, so what I'm going to do here is that instead of taking this one, instead of applying the 0 volt as one input to the digital system, 0.5 volts to the digital system, 1 volt to the digital system, instead of doing that one, I can combine all these things up to this point, for example. Okay, So up to this, so all these voltage values are treated as one logical value is called logical zero. Okay, so the digital information can be represented by a particular digit called zero. So logic zero stands for whatever the value that is available here. Clear? Similarly, for higher range of values, for example, these range of values, or maybe, okay, so from 3 volts onwards, for example. So all these things we will call it as, for example, logic 1. Okay, so I don't want to apply 0 volt, 0.5, 1 volt, 1.5 for something like this. Instead of, I can call it as logic 0 I'm applying to the digital system, or logic 0 is applied to the digital system. Or therefore, what I can say that if you consider any digital system here, so it is a series of zeros and logic zeros and logic ones. It is a series of logic zeros and logic ones. We are getting the output is also series of logic zeros and logic ones. Is it clear to all of you? So that is what we want to convert the physical phenomena into logical method, logical way. Okay. Now, so because of this logical method of representing the data or an information, we find some kind of advantages. Okay. So advantage. What is that? What is those advantages? Number one. So less effect to noise. So the digital systems are less noise effect. Those are the noise cannot affect the digital system much. Suppose since an input signal come from some other circuitry also. So, or maybe the signal may fluctuate because of some unwanted voltage fluctuations, for example. So if the noise is presented, for example, if I consider that, if I consider this one, for example, if somehow because of some fluctuation, the logic zero value is, so I want to apply for example, logic zero, especially the physical values, for example, 0.5 volts I want to apply. Okay, so because of noise, it becomes 1 volt, but I'm applying the 0.5 volts. Okay, but because of noise, it becomes 1 volt. Because the electrical signal may be influenced by other noise signals also. Noise will come into the picture because of so many reasons. Okay, so if the input voltage is changing from 0 volts to something like this, 0 volts to 0.5 volts to 1 volt, something like this, it cannot affect the logic zero value. It cannot affect the logic zero value. Why? Because 1 volt is also under this logic zero range only. Is it clear? So therefore, even the physical values are affected by the noise signal, noise information, that information cannot affect the logic zero value, so that the digital system cannot be affected by the noise signal, right? So therefore, what we can say that, so I can simply write one word. So as long as the noise is present in the given ranges of limits of the digital logical values, limits of logical values, the systems remains work perfectly. The digital system cannot be affected by noise, right? So that's what we observe, that this is because of we are using the logical information. Okay, of course there will be a possibilities there. So as I mentioned, that one word, very important word that we have to understand here. So the range of limit. Okay, what does it mean? Generally, ideally speaking, actually from 0 volts to ideally from 0 volts to, for example, middle point 2.5 volts we treated as logic 0. From 2.5 volts to 5 volts we treated as logic 1. This is ideally, but it's not possible to maintain that range. Okay, there is a 2.5 2.5 ambiguity will be there. So in that one, what actually in the reality what we do is that from 0 volts to 1.5 volts we treated as a logic 0, and 3.5 volts to 5 volts we treated as logic 1. So therefore what is in between? What is in between? For example, you consider something like this. For example, it says 0 volts. For example, it says 5 volts. Okay, so therefore we have no problem with this one. Okay, so I'll write here is, so from this point to this point. So what is this one? We can call it as 3.5 volts. Okay, so what about this one now? These ranges. So this is called 1.5 volts. So 1.5 volts. Okay, so only this region we can call it as logic 0. This region we will call it as logic 1. Right? So in between that one is an ambiguity is there. So forbidden region. So the signal, suppose the noise signal is involved within this range, automatically it can affect the system. Okay, so that's what the limited range of logical value, the noise will be taken into consideration. Okay, so that's it. So this is one of the advantages of the digital system. So because the ranges we are considering, noise that cannot be affected that much. Okay, the second very important point is it's easy of design. Easy of design. Easy of design. What does it mean? Easy of design. So normally, whatever the digital system is there, that will be constituted by or constructed by switching devices. Why? Because the logic 0 can be called as, sometimes we can call something like this also. Logic 0, as I mentioned, right? Okay, I'll write here is. Normally, logic 0 means we can say that off also. Only two states. Logic 1 stands for on. Sometimes it is also possible to call it as true. Sorry. Sometimes it is possible to call it as false. Sometimes it is called as true. Okay, that means that any device that must be operated only in these two regions only, either on or off. Okay, therefore, because whatever the signal that I'm applying to the digital system having the nature of either logic 0 or logic 1. That means that for these input signals, the device must be on or off. Okay, therefore, we are going to use the switching circuitry or switching devices within the digital system. Okay, that means a digital system is constituted by or constructed by switching devices. So whenever we have a device having only two possible states of operation, it's easy to design. Right. So therefore, what I can write it here is that the digital system is constructed by switching elements or switching devices. So what is the responsibility of the switching devices? It only on or off, that's all. It is only on and off, that's all. So that's only the thing is there. So we don't want to bother about the physics of this device is not required that much. Okay, so only whenever you apply the logic 0, it will be off. Whenever the logic 1 you apply, it will be on. So the only the switching devices we use. Therefore, I can simply write, therefore, digital system is nothing but a switching circuitry. What we can call it as switching circuit. switching circuit. Clear? So that's the reason whenever we have a switching circuitry, the design is very easy. Okay. So the third important point is so many are there. So some few advantages that I want to write it here. And it's easy to fabricate, easy fabrication, easy fabrication. Fabrication means manufacturing. Fabrication means manufacturing. Whenever we are using the switching devices in your switching circuitry, those switching devices are nothing but a transistor. Okay, so the transistor is that too MOS transistor that we use. Okay, so you might have seen that transistor. What do you mean by a transistor? Okay, so since the switching devices uses, or I can say that MOS transistors, I can simply write it as a MOS transistors as a switching devices. Since MOS field effect transistors are considered as switching devices. Switching devices. So whenever we have a MOS devices, these are very easy to fabricate on a silicon chip. Okay, so you have to remember that MOSFETs that we normally use. So whenever we have a MOSFETs are there, these are all switching devices. Okay. So whenever we have a MOSFETs, so it is easy now. It is easy to manufacture in silicon chip. So that's what the advantage. Therefore, the MOSFET has a great history. Why this digital era is digital concepts are popular because of the MOSFET field effect transistors only. Okay, so therefore these are the very advantageous things are there for this one. Therefore, the fab manufacturing on a silicon chip is easy because of the field effect transistors we are using, right? So apart from this one, so many are there, but I will try another one. Okay, so cost effect, less cost, or cost effect, economical. So I can simply, there are more economical. And one more thing is that less power consumed. So whenever we have a digital system compared to the analog systems, power consumption is low, less power consumption. Okay, whenever the digital system you're using, it consumes less power from the power supplies. Okay, and the fast speed is also good. So fast speed is good. Okay, high speed is possible with this one, so etc. So many are there. Okay, so the mandatory things that I have shown here, so please identify, these are the different advantages of the digital system. Okay, so please observe that these things you have to. So mandatory thing is that affect the design, and the second one is, the first one is the noise problem. There won't be any kind of noise. Design is very easy, fabrication is very good, and then power consumption, high speed, and cost is also will be manageable thing when compared to the analog systems. Okay, so far so good. Now we are going to look at another concept called a number system. Okay, so whatever the data that we have seen so far, that must be represented in the form of a number. Okay, why we are using the numbers generally? In order to count something. So if you want to count the money, or if you want to count the number of benches in your classroom, or if you want to count the number of chairs in your classroom. So if you want to count something, okay, you have to use the numbers, right? So similarly, if you want to represent a data, we are going to use a number. Okay, so I'm going to write here is a number system. Number system. Okay. So carefully listen this one, that's very important one. Okay. So whatever the digital data is there, the digital data is represented by, in fact, not only the digital data, any data is represented by a number, Okay, so these numbers are nothing but, a number is nothing but collection of digits. What do you mean by number actually? It's a collection of digits. So I can simply write the number is a collection of digits. What do you mean by a digit? Normally, we can consider it if we have a finger in this, sorry, in your hand, you can find 5 fingers are there. Okay, so one finger we can call it as a digit. Okay, so like this, how many digits are there in our hand? So 10 digits are there. Okay, so therefore, a number is something like a collection of digits. For example, 2, 7, 3, 2, 1. Okay, so 2 is 1 digit, 7 is 1 digit, 3 is 1 digit, 2 is 1 digit, 1 is 1 digit. So it's a collection of a digit. So example for this number is something like this, right? So depending upon how many number of digits that you are using, a number system is established. A number system is established based on how many number of digits that you are using for your counting purpose. Okay, so what do you mean by this one? I'll write one point here. The number system means the number of digits used, or I can say that the general word where I will write. So what do you mean by number system? General word where I'll write it. Okay, depending on the number of digits, the number system is defined. Okay, how many number of digits that you're using for your counting purpose, for example? For example, you can see here, if I'm using the 2 digits, for example, okay, so this is called a certain number system. Okay, it is a number system. So whenever how many number of digits are we are using, so normally what we can see that the number of digits are nothing but, it is nothing but the radix of that number. Number of digits is nothing but radix. For example, if you are using the 2 digits that you are using for your number system, so therefore what we can call it as this one, it is called radix 2 number system, radix 2. So therefore what is this number system we can call it as now? What we can call it as now? Radix 2 number system. Right? So only 2 digits only we have to consider. The question is that what are those 2 digits? So we can start from something like this. We can start from 0, 1. Only these 2 digits. Whatever the big number that you want to represent, we have to use only these 2 digits. That's all. Right? So therefore, for example, I'll write one thing. So for example, 1 0 1 0 1 1 0 1. So this is a big number. For example, A is equal to something like this. So this is one big number. That means you can see in this number, we don't find any other digit other than 0 and 1. For example, A is equal to 102101110. Can we call this as a radix 2 number system? If I say that A is a radix 2 number system, can we call this as a radix number 2 system? No. Why? Because we find that another digit is coming to the picture. 2 is coming to the picture. So, but our requirement is only we have to use 0 and 1 only, but 2 is coming to the picture. So it's not a radix 2 number system. So it's not radix 2. It is not radix 2, but it is radix 2 system. Okay, so that's the one way of one number system that we normally call it as. For example, 3 digits that I want to use. Okay. So, for example, what are those 3 digits? For example, 0, 1, 2 only. As we know that 2 digits. So, what is this system is called? It is called radix 3 number system. So, we need normally call it as a radix 3 number system. Radix 3 number system. Radix 3 number system. So that means the number consists of, so now, now can we call this is a radix 3 number system? Obviously, this is a radix 3 number system. Okay, there is no doubt at all. You can observe that there is no doubt. This is the radix 2 number system. Right. So therefore, we have to consider that this is a radix 2 number system. This is the radix 2 number system. Because of course, 0 and 1 is required for radix 3 number system. Of course, how many number of ones, how many number of zeros are not necessary to consider, but whether the upper limit is available or not, we have to check. About that, we can say that. Okay, so usual practice is whenever you are representing some number, okay, usual practice is we have to write at the bottom its radix value. Its radix value. By looking at this bottom one, we can say that that's a radix 2 number system. So like this, it is also, we can write this is a radix 3 number system. It's radix 3 number system. For example, you take another one. For example, you take 4, for example. 4 digits that I want to use to represent any number. Okay, what are those numbers that I can consider? 0, 1, 2, 3. So these are the 4 digits I want to use for any number to represent. So in that case, this is called radix.
Radix 4.
Yeah. You have doubt? Please ask.
No, sir.
No, sir.
Yeah. So fine, we can place it here. So it is called radix 4 number system. Radix 4 number system. Like this, how many number of radix that I can do here? N number, I can do it here. But usual practice, we don't want to do all those things. Okay, radix 5 is there. Okay, so we can use 5. You can 6, we can use it there. 7, we can use it. 7 digits, I can use it. 8 digits, I can use it. 9 digits, I can use it. 10 digits, I can use it. 11 digits, I can use it. 12, I can use it. 13 digits, I can use it. 14 digits, I can use it. 15 digits, I can use it. And 16 digits also, I can use it. Like this, so n number, I can do it. But these are the usual number systems that we normally consider. Quickly, I will write it, and then you can also find out that one. Okay, so what are the number systems? How many digits that we can use it? 0, 1, 2, 3, and 4. Right. So for the number 60 digits means how many digits I can use it? What are the different digits? 0, 1, 2, 3, 4, 5. Okay. So only 6 digits I can use it there. So this is called 0, 1, 2, 3, 4, 5, 6. Next, for if suppose 8 means 0, 1, 2, 3, 4, 5, 6, 7.
Sir, then writing all those, we can consider that number as n and we can return as 0 to n minus 1.
Yeah, exactly. We can write it also there. So the point I want to write it here is a different way. That's the one I can write it. Okay. So 7 should be there, or yes, 8 is also there. Like this, I have to write here. So what is the maximum number that the radix, for example, if I say that radix 12 I am writing, for example, radix 10. What is the maximum number digit that I can present here that should be there in it? Any guess? Radix 12. By the way, what is the numbers that I can present here now? What are the digits? So, okay, let me complete this one so that you can understand that point. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. So up to the only these digits only we know very well. So what about other numbers? Okay, so after 10 I cannot write there, because if I write 10, for example, here you consider 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 I cannot write. Why? Because 1 and 0 digits are available here. 1 and 0 digits are available here. Therefore, I should not write directly 10 there. Instead, I'm going to use another digit that is called A. Another digit is called A. Clear? So that is called A. So only I have to write. For example, what is the example for this one? What is the example number? For example, A is equal to 7, 3, 2, 1, A, 0. Okay, A, 2, 1, 0, something like this. So this is the one number in that particular radix system. So it consisting of A. So therefore, you may ask the question, sir, suppose, let us consider this one also. Okay, so that I can complete this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So no, it's not possible, right? So instead I can write it A comma B, I'll write it here. Okay, so you can see that, for example, the same number I'm writing here. Same number that I'm writing here, for example, this is the same number. Copy, I want to paste it here. So what is the big difference here, whether it is a radix 11 system or a radix 2 number system? How can you define this one? Because A is available to the radix 11 and radix 12 also. Then how do we define whether it is a radix 2 system, radix 12 system, or radix 11 system? That is based on what is the representation that we are doing here. So we have to mention that it's a radix 12, so 11 radix system. Okay, so that means that, so whenever we are representing a number in some particular radix, that number is valid for the succeeding stage radix also. Is it clear? So whatever the number that we are using, succeeding stage radix also is accepting that particular number. But it is not possible to valid, it is not a valid number for the preceding stage radix system. Is it clear? It is not possible, but it is possible. That's what we can understand. So like this, we will go on and go and go. For example, 17, I will write here. For example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now A, B, C, D, E, F. Okay, these are the number systems. Okay, like this, we will go for the G. After G kellochu, H kellochu, I kellochu. So therefore the radix number will be increases, so and so and so forth. Okay, it's not restricted to only 16. Okay, it will go to the another n number of digits also, as much as possible. Up to Z also you can go it. There is no problem at all. Okay, so therefore this is called radix 16. Radix 16. Okay, so this is called radix 10. So where is the radix 10? It is called radix 10. So like this, we can write it all these numbers. Okay, my main point here is that, so I want to say one point here. What is the main point here is that, so this radix 2 number system, also call it as It is also called as binary number system. What we can call it as binary number system. So some specific name have been given for this number system. Okay, so very popular in the computer, for the computer systems. Okay, binary number system only we need to consider for digital systems in generally. Okay, and another important number system is sometimes we use octal. It is called Radix 7. Sorry, Radix 8. So this number system normally we will call it as octal number system. So a specific name have given number system, right? As very popular one is Radix 10 number system. This is called decimal number system. This is called decimal number system, right? So essential, these are the system numbers, these are the numbers systems that we normally use in our course, most of the cases. Okay, next, last one is Radix 16. This is called hexadecimal number system. So therefore, you can understand that Radix number can be anything, okay, anything, but the important number systems that we play with us, we play is binary number system, okay, next octal number system, decimal number system, and hexadecimal number system. If I ask you the question, how many number of digits that we have to use in decimal number system or Radix 10 number system? How many digits? So if I say the Radix 10 means, you can immediately say that 10 digits. If I say the decimal number system, if I ask, then you have to keep in your mind that it is a Radix 10 number system. Therefore, the 10 digits that we have to use. What are those 10 digits? 0 to 9. If I ask you to hexadecimal number digits, how many number of hexadecimal digits are there?
16.
You can immediately give us 16. So what are those things? 0 to 9 from A to F. Right? So that is what we have to, these are the different number systems that are available. Okay. So as I mentioned that it is not restricted to only the 16 only, it can be anything. Okay. So therefore I can write it essential. I can write it essential number systems. So essential number systems, what are the essential number systems that we normally consider so far? The first one is binary. The second one is octal. Next one is decimal. Last one is hexadecimal. Is it clear to all of you? Yeah.
Sir, we can write only 36, sir.
Yes, of course. We have only up to A to Z means how many digits are there?
Then
yeah.
what about 37 and so on, sir?
No, it's not possible to write. You have to use another number, then other digit that you have to do. You have to take. Okay.
Other digits means A to Z all will complete, no, sir?
Yeah,
up to 36
maybe some other digits also will be considered. Okay, maybe the Greek words, for example, some other things also possible, but nobody has extended more than that. Actually, they have restricted up to hexadecimal only. They have managed that one, but these are more than sufficient to represent any big number. Okay, so if you want to represent any big number, the 16 digits are more than sufficient as far as the today's words are concerned. Okay. So
okay,
they cannot go more than that one also. Not necessary to go more than that. Okay. So these are the, fine. So these are the number systems that we normally concentrated on in this particular course. Okay. So how we are representing a number in binary, how we are representing a particular number in octal, decimal, hexadecimal. How do we convert a binary to octal, octal to binary? How do we convert octal to decimal, decimal to octal? How do we convert the decimal to hexadecimal, hexadecimal to binary? So therefore, there are so many things that we want to communicate at this point of time. Okay, so by the by, so the final conclusion for this one is, let us consider one note. So the general representation of a number, representation of a number. What is that? So we write something like this. That, for example, A I'm considering is a one number is our number. It is from A n minus 1, A n minus 2, A n minus 3, so on and so forth, A3, A2, A1, A0. So these are all the coefficients, what we can call it as, these are all the coefficients. So therefore, if you give a value to a particular number, that coefficients are multiplied with its weights. I will tell you that weight also. So this is the general representation. If you want to put a decimal point here also, sometimes we point to 72.50, 73.20, something like this, right? So this is also possibilities there. Those are A minus 1, A minus 2, A minus 3, so on up to A minus M. So it is a complete number, okay, having the decimal part, having a fractional part also. Okay, so therefore, what is this from A0, A1, A2, A3, 0, 1, 2, 3, so on up to n minus 1, minus 1 to so on up to n. Let us consider this is generalized notation is I, for example. I should be there between minus m to n minus 1, right? So this is what the I value should remains there. So this is the range of the numbers, what we can call it as range of numbers. Range of coefficients also we can consider coefficients. Range of numbers are right. Range of coefficients. Coefficients is a better word. Okay. Okay, so therefore, the moment if I'm writing, for example, what does it mean? For example, 732.320. This is the one number I have given. Okay, can you guess what is this number system? Can you guess what is this number system quickly? It can be Radix. You can see the maximum digit available here. 7 is the maximum digit. Okay, so 7 is the maximum digit means what is this Radix system? Radix 8 can be possible. Okay, because so it is very important to note that one point here. If I'm writing the Radix 8 means, for example, Radix n. For example, Radix n. So how many digits are there in this one? So digits we know about depending upon this one. Therefore, the number of digits is is equal to n. There is no doubt. Okay. But what is the maximum digit? What is the maximum digit? What is the maximum digit here? It is n minus 1 that we have to remember. Okay, so Radix 8 for example, if I consider the Radix 8, for example, what do you observe that? 8 digits are required. There is no doubt at all. What is the maximum digit there? 8 minus 1. That means 7. Right. So by looking at this 7, we can say it's Radix 8. Or it may be called as, Radix 9 also possible. Right? Or Radix 10 is also possible to consider. So etc. So as I mentioned that whenever you find a maximum number, that can be about the succeeding number system will accept this number system, but preceding number system cannot be considered as this number system. Okay. Consider this is the Radix 8 number system. So what do you mean by this number actually says that it is the coefficient of the given number. So how do we give the value to this one? Means we have to multiply each coefficient with its weights. How do we do this one? So I'm writing here is a 2 is the, so 732.302. For example, for reduce the complexity, I don't want to use the fractional part. I consider only this. So this is called first column. This is the first column, second column, third column. Okay, fine. And so this is called, and it is also called as first position. Also, we can call it as second position. This is called third position. So normally these number systems are called positional number systems. Positional number systems. Positional number system. What is the positions are there? Positions consisting of only the coefficients. If you give a value to that the coefficient, what we have to do, we have to multiply the 2 with its weight. So what is its weight? How do we define the weight of a particular number? That is depending upon the radix value. What is the radix value that we have considered? Octal number system, octal. What is its position? 0th position. That is 0th position. So this will give you the value to that particular number. So plus, I have to give the plus, and you take another digit position, okay, and multiplied with it, and multiply with its weight. What is the position of, my weight is nothing but 8 radix, and what is its position? Second position, the second position. So that means 1. So 0th position means second position is 1 position. Next one is third position. So multiplied plus with, and 7 is multiplied with, what is its position? 8. Its position is 2, and third position. So if you add all these things, it will represent it in the form of a decimal number system. That is useful. That is humans are able to identify its number system in decimal. So all the humans are able to identify the decimal number system. Therefore, whenever its coefficients are multiplied with its weights of the number system, then we will convert that one into a decimal number system. Okay. So can anybody guess what is this value? Quickly, what is the value of this one? 64 plus 3 into 8 plus 2 into 1. What is value? This into is in form of decimal number system. Will come with the decimal number system. Okay, of course, if this point is not that much clear right now, so we will discuss the point later on. But you have to only identify that. What are the numbers? What do you mean by a number? What do you mean by a number system? What are the essential number system and general representation of a number? Yes, madam.
474, sir.
474. Okay, so this is. So we are very sure that once we are multiplying all these quotients with its coefficients, with its weights, damn sure that this number is actually it's a decimal number system. There is no doubt at all. Even if you're not writing the 10 there also, even if you're not writing this one, you immediately say that, frankly, you can say that it's a decimal number system. Okay, so but usual practice, we will write it in 10. Okay, fine. With this, we have come to the end of the today's session. If you have any doubt, please respond to the group or otherwise Moodles also. Okay, these lecture notes as well as a lecture video will be posted in the Moodles. All of you, please go through it once. Okay, at least you spend 10 to 15 minutes what I have discussed in the classroom, so that it won't be a burden for when you are taking an examination. Okay, so thank you very much. Thank you one and all. So my sincere request is, another sincere request for each and everyone